All right, so here's the homework video for 8.3. Again, I asked you to find critical values and where there's the locations of maximums and minimums. Don't forget, once we have the sign pattern of the derivative, we could also talk about where our function increases and decreases. So first thing I need to do, I need to establish my domain. So I've taken what's inside my square root, set it equal to 0. This one was factorable, but I find the zeros of what's inside my radical, set up a sign pattern of the function inside. Remember, this is not the sign pattern of the entire function. And I know that wherever my values are positive, I have my domain. So I establish my domain. I take my derivative, set my numerator equal to 0. Since I've already done the work to find where my denominator equals 0 up top, I already know that these values become, sorry, it erased. These values become vertical asymptotes in the derivative. I find the two zeros from my derivative, but one of them does not fit in my domain. Don't forget, zeros from our original function are critical values, as well as anything that we find that makes the derivative equal 0. I made my sign pattern for my derivative, and I know that where my sign pattern changes from positive to negative, I'll have a maximum. And at all the zeros from the original function in this problem, I will have a minimum. Number 7, again, I establish my domain by finding where what's inside the radical equals 0. Wherever it's positive is going to create my domain. Find my derivative. There's no way for my numerator to equal 0, so my only critical value is the 0 I got from the original function, and since it's a 0 of the original function, in this case, it is a minimum. Number 8, I have to take the time to find my zeros, find my vertical asymptotes. Again, I'm making a sign pattern of what's inside the radical. This is not the entire function y. From there, anywhere I'm positive I know is in my domain. And then just be careful with your parentheses and brackets. Was the boundary formed by a vertical asymptote or a 0? I go through again. The shortcut's not so good with fractions inside the radical, so I'm taking the time to do the derivative of my square root, my quotient rule. I do some simplifying. Now we already know anything that was a 0 of the original function becomes a vertical asymptote of the derivative. And then all I'm left with is to find out where does my negative 6x, where does my numerator equal 0? Well, that's at 0. You'll notice I'm ignoring the x squared minus 4 because I already know that that produces vertical asymptotes from the original. So my critical value, what makes my derivative equal 0? What made my original function equal 0 because this is a square root? I can make a sign pattern of my derivative, ignoring anywhere that wasn't in the domain. And I know that I've got a maximum at 0, and then minimums at x equals plus or minus 1 because those were zeros of the original function. Okay. Continuing this same process, I need to find my domain by setting what's inside the square root equal to 0. I focus on where those values are positive. So I already know that these are zeros of the original as well as critical values. Find my derivative using the shortcut. I did a little bit of simplifying, but you don't have to. Set our numerator equal to 0. I get two zeros. One of them does not fit in the domain. So I know I've got my critical value from when the derivative equals 0, and I've got my critical value for when the derivative didn't exist, or in other words, the zeros of the original function. I can ignore these places on my sign pattern because they aren't in the domain. I have a place where I change from positive to negative, so I've got a maximum there. And then anything that made my original function equal 0 is the location of a minimum. I set my original function inside the radical equal to 0. Find my zeros, which I know are also going to be critical values. Make my sign pattern again. This is of the function inside the radical, not the entire radical. And now I know my domain. Found my derivative. Careful, don't simplify the negative 2 and the 2 because we can't take 2 out of 5. Set my numerator equal to 0 and get 2.5, but 2.5 is not in my domain, so my only critical values were the values that made my original function equal 0, and I know that they, in this case, give us minimums. All right, multiple choice number 2 is a matter of being able to use the chart. I do my chain rule. f prime of g of x times g prime of x. I substitute in 1 for x. And then reading my chart, when x equals 1, g prime equals 2. When x equals 1, g equals negative 1. F prime of negative 1, so when x equals negative 1, y equals 5. And then finally, 5 times 2 is 10. And unfortunately, I can't remember which choice that was. All right. Remember, if you have questions, always feel free to ask in class. Happy to answer them. Hopefully this helped out, but if not, please ask questions in class.